Okay, so if you were here yesterday, you did like a little investigative lab on special segments that happen in a triangle. Today we're going to talk about two of those in detail.
Very good. This one first.
Yep. The first one is a perpendicular bisector. And just by using those two words, you've seen them before. Perpendicular, you should think
Right angle.
like a right angle. And bisector means to split in half, right? And it goes through the what, Chloe? It goes through the...
Middle.
Yeah, okay. So you take a second and read that first theorem, just so maybe you can understand it better before I talk about it. See, conceptualize what I'm saying.
Mr. Levin yelled at you.
He yells at me every day.
How do you think you gotta be like an annoying soccer hockey player to get Mr. Levin to yell at you?
Okay, so which one of my lines up here is my perpendicular bisector? CD, right? And you can tell there's your right angle. And how do you know it's bisecting AB?
Just go through
The tick marks. Perfect. So what this is saying is that C is your point, and it's equal distance from A and B. That's the whole point of this. So if you're given the perpendicular bisector, then C is equal distance from A and B. So that's what we're going to fill in right here. Then AC is congruent to CD.
Would it be BC?
Yep. Either or BC, CD. Same thing. Doesn't matter.
That's the only reason
Very much.
Okay, and then the converse is also true. Chatty Cathy in the middle.
Got him.
So if we know C, our point, is equal distance from the endpoints of a segment, then I know C is on the perpendicular bisector. So then I know CD is what to AB? What should I put here?
Right angle.
Perpendicular, so then CD is perpendicular to AB. And what congruence do we know? Yep, AD equals DB. Okay, let's try a few examples. How can we find the x here? Okay, here's your point C. There's your perpendicular bisector. So what do I know about this segment and this segment?
A is equal.
They're equal. What do you guys get for x? X should be 12. Okay, this time I know C is equal distance from my endpoints. So what kind of an angle is here?
Right.
A right angle. And then what I know about these two little segments? They're equal. So find x.
There's some words. Are there any proofs in this chat?
There'll be proofs for the rest of the year. They don't go away. Do you guys get x equals 2?
Yeah.
Good job.
I was just I'd be so good at it.
Alright, now we have the circumcenter. And this is the point where all three of your perpendicular bisectors intersect. Circumcenter is always equidistant from the vertices of the triangle. Equidistant just means the same length. Same length away.
What the fact that you spilled some water.
Alright, so let's list some of these things. What are my perpendicular bisectors? And how do you know? What should you look for?
Because the right angle.
You should look for the right angle, right? So here's one, DP. There's three of them, so there's one, PE. And my third one, PF.
Are you kidding? Trish?
What is our circumcenter? Point P. Now we need to list all congruent segments.
PE. And
Wait, let's go with what Reggie was saying. So first he said BP, because look right here. Oh, Reggie said that. They're all equidistant from the vertices. Here's a vertice. Here's a vertice. So all three of those green segments are congruent. So AP, BP, and PC. I still have more though.
oh, the blue ones.
Nope, the blue ones aren't congruent. But what are all these tick marks?
The ones on the side.
So what's congruent to AD?
BD.
BD.
Best song.
Okay, what about BE?
Easy.
EC. And what's my last pair? Yep. FC and AF. Okay, the side conversation needs to stop. We don't care who it is, let's just stop. Let it stop. Okay, let's see if we can find all of these lengths now. How can we find TU? Is he right? 19 plus
Yeah.
19? What about BY? 34 divided by 2?
Yeah.
17.
UZ. Right? How are we going to find that one?
Equal distance to VZ.
Is he right? Is it the same distance as VZ?
Yes.
Sure is. 21. WV. WV. Do we know anything about that one?
Yeah, it's the same as VY.
No, it's not. Ooh, I heard it. What's right here?
Right
A right angle. What can you use to find the missing side of a right triangle? Pythagorean theorem. So 15 squared plus x squared equals 21 squared. $225 plus x squared. I don't remember what what's one. It's 21 squared. Anyone have a calculator?
I got it.
441.
now.
441 minus 25 is what? 216, right? Square root of 216. 14.7. Good job. And how are we going to find TV?
Equidistance.
Remember, this is the midpoint, so 14.
14.7 times 2.
Yep, plus 14.7.
29.4.
All right, take a second, read those theorems about the angle bisectors.
We're gonna have to remember the names of this stuff.
No.
Not for pros even.
Now let's just look at the picture. You guys agree AD is cutting this big angle in half, right?
Yeah.
So it's called an angle bisector. And what this theorem says is any point on this line here is equal distances from both sides of the angle. Okay? So then in this picture, what two things would be equal? Yep, BD is congruent to DC. And then the opposite is also true. So if I know D is on this line here, and it's equal distance from the sides of my angle, then what do I know about AD?
Here's the angle plus.
It's an angle bisector.
That's it.
Can we get a blue stick?
Yep. Okay, how are we going to find X here? What do we know?
Set them equal to each other.
Yep, set them equal to each other. Did you guys get 7?
Yes.
Awesome. What about this one? Do you know anything about those angles? They're congruent because we know that this has to be our angle bisector.
Absolutely.
You guys get 3?
Isn't it?
I mean, 10's what I meant. 30 divided by 3 is 10, not 3. Okay, and the last thing we need to talk about is the in-center. And that is where all of your angle bisectors, it should be plural, intersect. The in-center is always equidistant from the sides of the triangle. Okay, let's see what we can fill out here. What are the angle bisectors? BP is 1, AP is 1, and
CV.
good job. What's our in-center? Point P. Oh boy, what are our congruent segments?
DP.
Yep, all the middle guys.
Yep.
These are all equal. P and PF. All right. Do we know anything congruent to AD? You guys know anything? Yep, AF. Remember, these guys are equal. So now let's work our way around. What about FC? EC. What's our last congruence? Yep. Alright. Let's see if we can put it all together. My thing shorts out. I don't know why it doesn't always work. It shorts out. Alright, do we know what NP is, guys?
Equidistant.
8.
Yep, remember these ones are all the same. So they're all 8.
Yes.
Perfect. And K?
17.
17.
Perfect. So we know this guy is equal to this guy.
Good one.
Yeah.
TK. What's this right here? What did we say NP was? 8. What kind of an angle's right here?
Right.
All right.
And that's 17. So what can we use?
Pythagorean.
Pythagorean theorem.
British Siri, what is 17 squared?
Here's what I found on the web for British Siri. What is 17 squared?
289.
No, it's not me, it's British Siri.
64 plus 289 is what?
355 minus.
Oops, that's an equals. And what's the square root of 355?
A big number.
Do we ask British
Like
Siri?
18 something.
British Siri, what is the square root of 350?
355.
Okay, I found this on the web for British series. What is the square?
He looks up a musician thing. There's a series actually useless.
Someone has to have a calculator.
I do, but it won't go sideways for me.
I'll knock your contract go sideways.
Yeah, sure.
First world problems.
Boom. Classic calculator.
I was thinking
18.84.
All right, 18.9.
We don't round that.
Nothing.
8.4, so 18.8. Huh? It's 353.
Yeah.
Reggie, no.
That's okay.
Reggie.
What's the square root of 353?
18 points. It'd be the same thing.
Yeah.
2.8.
Hey, enough. All right,
Poor Reggie alone.
how are we gonna find
Good job, Reggie.
LO?
X squared plus B squared equals 13 squared.
Yeah. Mark with Adrian's theorem. This is 8. It's a right angle.
It's
102. 13 is 169. I know that because. Yeah.
10 point what? 2, 3, 1?
10.5.
It's not 10.5. It's hardly over 100. 10.1?
Yeah.
I got this.
10.2.
Okay.
All day. Gross.
There's homework. It's a book assignment, but it's a lot, I think, easier than what we just did.
I said,
Right here.